Hi everyone, welcome to this short tutorial on the problem solving aspects of quantum theory of light. Now, as discussed in the earlier class, we had spoken about the theory and the important concepts which were there in the quantum theory of light. In this particular video, I would like to go into the details of problem solving, that what kind of approach one should take while solving questions based on quantum theory of light. So as a quick recap of the concepts that we studied, like the first concept that we understood in the quantum theory of light was that electromagnetic radiation is quantized, and how we understand it mathematically is that energy of light is made up of small discrete units called as quanta or photons, right? So for a light which is monochromatic, monochromatic means of a particular wavelength only or a particular frequency, the energy, the total energy present in that electromagnetic radiation is made up of the sum of energy of its photons, right? So here n represents the number of photons and e photon represents the energy of a single photon, right? That is what we call as the quanta of energy. Then another concept that emerged from Planck's theory was that energy of a photon is directly proportional to its frequency, right? So energy of a photon is directly proportional to its frequency or inversely proportional to its wavelength. And that proportionality is converted into a mathematical equation using Planck's constant, which I had asked you to remember the value of in SI units. Now, if I combine these two equations, what I simply get is that the energy of light, that the total energy present in a beam of electromagnetic radiation, can be written as n times h nu or n times hc by lambda. Now, this is the primary equation that we will be seeing while solving questions in this particular concept. So let's go through a couple of questions. We'll start with a very simple one in the first place. So there is a bulb which uses certain power and then uses that power, uses that energy and converts some of it into visible light of wavelength 550 nanometers. Now, a question is asking that how many photons of this wavelength are emitted by the light bulb in 1 second. So now we'll try to comprehend the question, like try to visualize what is happening. So there is a bulb in which consumes certain energy. There is an amount of energy that is supplied to it. And based on your junior class knowledge, I hope you remember the formula of power. And based on that, you are able to understand that what was the energy supplied to the bulb. It is power into time, where time is mentioned as 1 second and power is given as 75 watts. Now this energy is supplied and only 15% of it is being emitted as light, as this particular light of wavelength 550 nanometer. Now using the quantum theory of light, I can substitute that this energy of light is equal to nhc by lambda, right? And use the information given in the question. Now if you will notice, I initially work with symbols rather than substituting values right from the beginning. It helps me save time. I will only substitute values towards the end when I'm sure that, okay, I have understood the question, I have made the equations, and then I need to do the solving, right? Because if you put values in the beginning itself, then it will lead to, it increases your chances of committing a careless mistake. So you go use the symbols as much as possible, form the equations, and then towards the end, put the values, substitute the values. Now, while substituting values, as you can see, it is extremely important to take care of units. This is again quite important. Now, sometimes the data given in the question is in SI units, but sometimes it is not in SI units. So while substituting the values, you have to follow a consistent set of units so that you get the correct answer. So यहाँ पर power and time were given in the SI units, so we substitute the values as it is. Now h का value in SI unit is something that we know. C, that is speed of light का value is also something that we know. Now wavelength here, right? It was given in nanometers, so it became important for you to convert it into meters first, then substitute over here, and then solve to get the value of n. Now while solving also, like it is a skill set that you will acquire over time, that you deal with the 10 ka powers in one way and the other values which are present in other way. It helps you simplify your calculation. So yahan par, this is a mathematical aspect wherein I have got the equation in front of me. N is what I have to calculate, so I will be rejigging these terms around n, and these 10 ka powers I will be segregating in one cluster, and I will be segregating these values in another cluster and solving them independently. So this kind of gives me a more clean and a nice way of solving the mathematical aspect. So once done, your answer should come something like this. Right. So as a quick recap, what were the important points? You comprehend the question and you start working. Once you read the question, you first remember that what concept this question is based on. And once that strikes to you that, okay, this is based on quantum theory of light, then you should be able to remember the concepts that you studied in quantum theory of light. The concept was that energy of light is quantized and it can be mathematically written in this particular way. All right, let's try another question. So this is the question in front of you. You can pause the video if you want, take an attempt by yourself and solve for it. Now, if you would have tried to do the question, one of the things that would have been a little uncomfortable to start with is the language of the question, right? There is like a certain reptile, the eye, the visual signal, the brain. You like whether this is biology or this is physics or this is chemistry, like we don't understand, but that's okay. What you need to do is understand and comprehend the language and try to create a sequence or a flow of what things are happening, right? So yahan par aap notice karo that there is this statement that eyes of a certain reptile family pass visual signal to a brain. Okay, so there is eye which is passing a visual signal to the brain, right? This is a representation of the brain, and in order to do so, right, when it happens, it is going to happen when it is struck by photons of wavelength 890 nanometers. So here is a drawing of the photons and the light that is striking the eye. Now you capture the data also simultaneously that, okay, wavelength of 890 nanometer is coming in and the energy required is 3.15 into 10 raised to the power of minus 14 joule. Now, after comprehending the language of this question, the next you come to is trying to understand how you can formulate the equation, right? So, my bad. So yahan par, now you notice that, okay, again, the question lies around, photons and counting of photons. So you are able to connect it back to the quantum theory of light and remember the concept that the energy of incident radiation is quantized and can be written as n times energy of a photon, which is hc by lambda. So now here we understand this energy that is required to send the signal from eye to brain is coming from light only. And this energy of light can be written in form of nhc by lambda. So now rereading the question, we understand this energy required is given to us, right? Wavelength is given to us and n is being asked, right? And of course, h and c are constant values, jinka values you must remember. H and C are something which you should know. So upon formulating this equation, you got the comfort that, okay, we have the equation, we have the unknown, we have the knowns, we start now solving for it. So as I said, again, go for the SI units while solving the questions. Later, I will also talk about another unit which will be easier to work with. It's electron volts ka unit. But however, it is something which is a concept in itself. So we'll cover that in the upcoming classes. Right now, focus on the SI units. So you have the equation, you have the values in front of you, and then you again try to solve. You solve via the same approach that I had spoken earlier. Like you segregate the 10 ka powers alag se, and then try to come up with the answer. Now notice there is one important technique also here, that if you observe the question, it's an objective question with options given to you, right? So if you carefully look at the options that were given in the question, right, 10 raised to the power of 19, 10 raised to the power of 9, 10 raised to the power of 5, 10 raised to the power of 10. So the options are quite far off from each other, right? So even if I work with the proper power of 10, I might be able to get the correct answer. Rather than getting into the details of what is associated with the power of 10, which might waste my time, I'll just try to work with the first power of 10 only. So yahan par what I did was I segregated the power of 10. However, there is one small thing which I have also done over here, that I have written 890 as 8.9 into 10 raised to the power of 10, right? So that what I have, as a cluster of values which are not required to be solved, they tend to be between 1 and 10 only, right? So that what I have with the power of 10 is something which is accurate, right? So this is something which you will learn with time. This is more of maths rather than chemistry or physics. This is something which is a technique which you will hone over time only, like the more you practice. Some students, especially the students who are in CBSE and ICSE, are more equipped to work with this. I generally find that students who are from IB or IGCSE, they are going to struggle a bit with this kind of problem solving, right? So coming to this, like when you solve for the power of 10, you get that it is coming out to be around 10 raised to the power of 5. And I'm not wasting my time on solving this part. It will be somewhere between 1 and 10, but that's okay. But because this is coming out to be around 10 raised to the power of 5, I straight away look at the options, and because the options are far away from each other, I will just be quick in terms of answering that. Okay, C option is the correct answer. All right. So this was a question in which multiple things were to be learned. One was comprehension of the language. The other was, neatly segregating what is given and what is being asked in the equation of the concept. And then, of course, the problem solving aspect, the numerical aspect, wherein you look at how the options are and then adjust your calculations to save time. All right. Another question. You can again pause and take an attempt yourself. Now, we'll have that same consistent approach. We'll first try to comprehend the language of the question. That, okay, there is a certain dye that absorbs light of certain wavelength and emits light of certain wavelength. So, okay, there is a dye which is absorbing light of 4,500 angstrom and emitting light of 5,000 angstrom. And assuming under the given conditions that 50% of the absorbed energy is emitted out, right, as fluorescence, so it is simply saying that it is emitted out, then calculate the ratio of quanta emitted to the number of quanta absorbed. What is meant by quanta? Quanta is photons only. Okay, so like I can put some variables over here that say NA number of photons are getting absorbed and NE number of photons are getting emitted. Right, and the ratio is what I'm being asked in the question. Now, again, how do I relate this? How do I relate this piece of information, with absorbed energy and emitted energy? So I again reread the language of the question and I find out that, okay, 50% of the absorbed energy is emitted. So I'll use that as a concept. 50% of the absorbed energy is being emitted. Now, how do I write absorbed or emitted energy in terms of photons and wavelength? And that is where again you strike upon the quantum theory of light and its concept that energy can be written as nhc by lambda, right? So that's what we did here. Again, we substituted that energy absorbed is number of photons absorbed into hc by lambda of absorbed photons, and energy emitted is number of photons emitted into hc by lambda of the photons emitted. Again, working with symbols gave me an advantage that I could easily cancel out certain things without getting into the numerical problems of it. So that is where this aspect of working with symbols first comes in handy. And then I calculated the ratio of Ne upon Na, which is lambda E by lambda A into 50 by 1000. Now you substitute the values again, because it is a ratio that you need to calculate. So there's no need to put in everything in SI units, because again, things are going to cancel out only. Angstrom cancels out. And then you substituted these values and calculated your answer. It comes out to be equal to option A, that is 0.55. Right. So I hope that these couple of questions were, sufficient for you to understand how quantum theory of light is to be used in certain such concepts, certain such questions, right? You wouldn't every time get a question, which is like directly based on the formula, that, like E दे दिया, H C पता है, lambda दे दिया और N निकालना है. Like एकदम simple language नहीं रहेगा question का. It will sometimes be, formulated in a way that it asks you to think and, make a visualization in your mind that what is happening. And this is the time for you to then develop that problem solving approach. And even like after getting the problem solving approach right, the battle is half won, because a lot of students commit mistakes in units and doing this problem solving, doing this numerical problem solving. So this is also an important skill set जिसका कोई shortcut नहीं है. There is no shortcut for it. You need to practice as much as you can to become better at this. All right, so that's it, guys. Thank you from my side. I hope you understood the tutorial, and based on it, then I'm going to send some homework for you, so you can practice that, and then we can discuss that in the next class.